part 2. So we are on example 8 part 2. Okay, once again, this question has been done using partial fractions. Apparently, this fraction, right, is actually a proper fraction. What is the form of this partial fraction? Okay, let's start the ball rolling with Jethro. What do you think is the form of this partial fraction? A over x minus 1. Right. So like this is a good illustration for me to stress that sometimes you just have to remember the form of the partial fraction. Of course, you can also do it by logic, you know. The numerator must be always 1 degree lower than the denominator. Okay, Jethro, press on. What do you think is A? Do you say minus 1? You said minus 1, right?
I think I did that.
Okay. What is B? Do you say B is 2?
I think so. I thought just say yes.
How about your C? Minus C plus A. So it's minus 1 minus C. So I think C is 2. Anybody else got any? C is 2. Right, thank you. So once you break it up into partial fractions, Jethro, press on. How do you go on from here? What's the integration of 1 over? How about the other one? Not quite. You can bring the two integrations. And then go on, say the last one. Right. And once again, it is because I have memorized all this formulae, you know, right? Over time, I use it a lot of times in classrooms. It became second nature, right? So the next one we will have Gregory. You see here, Gregory, are you ready? On part 2, is it? Okay, let's put for you. Okay, so let's spare him for a moment. Let's have Gyro. Are you ready for part 3, Gyro? Once again, what's the form of the partial fractions? Yeah, right. Just that I have written the A first, you know. But it's the same, okay? It's the same. Okay, let me ask Gyro. Gyro, what do you think is B? Right, B is negative 2. What do you think is C? Right? And then we are stuck with A. So you will have by your side of working 4 equals to A x minus 2 plus B x minus 2 plus C x square, right? So therefore you will see that A has to be the opposite of C. So therefore A has to be minus 1. You agree or not? So our calculation therefore use this partial fraction that is minus 1 over x minus 2 over. Okay, in case I'm wrong, let me know. No, this partial fraction thing. I'm sure Yu Tong has already completed example 8. Right? Bayo, don't have. Okay, you're too busy with counselor thing. So when do you get your appointment?
Like for extra.
Ah,
We haven't had our campaign yet. So.
or haven't had campaign for the different roles. Okay. It's of course good to have an appointment. There are only 4 main appointments, right? The president, vice president, the secretary, and treasurer. These are 4 main. Okay. What are the likely one to be president? Aditi. Aditi. Oh, that's very good. Okay. So Aditi has a good chance, Okay. She went for the interview, is it actually? Or what? Is that interview or something?
No.
It's just by campaigning.
There'll be an interview with the school.
Okay.
But we haven't gone.
Okay. So as you're jotting down, let me ask you this question again. Do you think that it's nice to have a bigger cohort, means more people in school? Do you think it's nice? Our school size are very small. Like we should have more students. Because in my JC, right, in my JC days, our J1, J2 are all about the same age group. All add in, I think we have at least 1,005.
Oh.
Yeah.
Already more than.
Yeah.
Wait, that's more than the entire.
And just highlight. No. Our whole school population, but yeah, you're right. He's right. But our school size about 1,000. But I remember in my JC days, we have quite a lot of people.
2 levels.
Yeah, 2 levels add up together is 1,005.
So then how many?
And our entire school is 1K. How many
Our class size is bigger also.
Like,
Maybe
there's so many classes.
30 people.
Oh,
30. Yeah, about 30 now. Last time ASI is about 20 only. Last time. So bigger course nicer, right? Got more people to rub shoulder with, I think. Let's go. Okay, now let's revisit this formula. We saw this formula when we talked about integration. This was my formula number. Okay. Chimaya, I label this as formula number what? What number is this formula? This formula. Remember when I list down a list of formulae? This was my formula what? Is it formula 5, 6 or 7? It's 1. Right? I listed it as formula 1. You said 1 Chimaya, you said 1 Okay. Yeah, that was my formula 1. This is the simplest formula. Actually, this formula came from this, This formula came from this formula. And what I simply did was, I so-called generalize this formula. You want to learn how to generalize a formula. Let me show you how do you go about generalizing a formula. To generalize a formula, right, all you needed to do is to replace the x with fx. Replace all the x with fx. Okay, Chimaya, do you see what I'm doing? But there is a missing piece. When you generalize a formula, the blue color means something. You need that magic touch. What is that? What do you say? Okay, the restriction for both of them are the same, that n cannot be minus 1. But there is something that's missing in this blue color. What is that? Huh? Appendix. Right. Right in front, said it is f prime x. You just put f prime x in front, you would have generalized this formula. This method of generalizing a formula is across the board only. I will show you another way, another example, okay, how we can generalize a formula. For example, okay, I have this one. Okay, this one, we have memorized this one to be sine inverse of x. Class, I can so-called generalize this formula. How do I generalize this formula? Replace all the x with, and then you need a magic touch. Chimbaya, what is that? You're saying f prime x, right? And after doing so, the formula now becomes, and to demonstrate to me that you have understood what I just said, could you all try this question? Say again, half? Right. Because you will write this thing as half integration to x so that becomes half sine inverse of x squared. And you don't need a substitution, you know. I know that some people who resort to substitution for this, but you don't have to. You can actually do it without. So with this idea about generalizing a formula, you can actually create many more general formulae, you know, your own on your own. Let me, yep. Okay. Let's do number 9 using formula 1. Let's have James. I have to return James your assignment 1, which I marked. I marked assignment 1. I haven't written you back. Quite okay, quite alright. Yep. Okay, James. Negative cos of divided by. Brilliant. Next one. Brilliant. Divide by 2. And lastly, wow. What can I say? Impressive. Yeah, impressive. Okay. Not bad. So James can go register for the A-level exam, you know. I'm sure he passed with flying colours. Okay. Anybody has problem with these few questions? For the last one, what James was thinking of was this thing, no? He used the so-called formula 3. I have a formula 3, you know. Do you remember what's my formula 3? My formula 3 was like this. My formula 3 was like that. Yo. There. Okay, I messed up the minus. Thank you, Kailash. Okay, any question to raise for example 9? Good? Okay. Jimmy didn't sleep last night.
I did.
You didn't sleep well or something? Yep. Part 2 is it? Part 2 is because what he saw this is, he saw this as like that. You saw as formula 1. That way, right? This becomes your f prime, and this is your fx. In this case, is the power 1. It's all in your mind, right? Yeah. Interestingly, there was once I said a question like this, no? And students cried their head though, they didn't know how to do this question. Okay, let's just test things out now. Lawrence here, right? Lawrence, how do you indicate this? Right, yeah, it's just tangent, no? So you don't see that, if you cannot see that it's secant square to start with, right? You probably won't think it's tangent, is it? Yeah. So it's all in your mind. You need to have a good pair of eyes, good eyesight. If you see it, you see it. No? Okay. So for the next question, right? The working below is very lengthy, you know, but it is basically doing this. Okay, this question, it is not entirely formula 3. Do you remember formula 3? What's formula 3? No, formula 3 was this one. When you see this question, right? When you see this question, like example 10, the thing that should cross your mind first is actually formula 3. But you know that it's not entirely formula 3, because to make formula 3 to appear, what I need is actually like this. To make formula 3 to appear, I need this. But you know that it's not balanced, right? It's not balanced because introducing the extra term inside the integrand makes it imbalanced. But you want formula 3 to appear, and to balance it off, what I need? You need, why not? To balance it off, you need a 3. And then now you know, if you're in this trade for a long time, you know that for the second fraction, you do not want to write in the same way. Then write as like this. If you can see the red and the blue like the way I've done it, then you can avoid the lengthy calculation that's shown in your notes, you know. You don't have to, no. So the whole idea is to make formula 3 appear first, and then you know that you will need formula 6. What was my formula 6? Do you remember?
The sine inverse.
Right, the a square minus bx plus d square. So at the onset, if you can see like this, right, then you can avoid the lengthy working that's shown in your notes. No, you don't have to. So once everything in this manner, you will immediately apply the known formulae. This becomes just minus. So it's like maybe a 2-liner solution, you know. Yeah, you can present like this. It's a good solution. In 2 lines, you're done. The lengthy calculation give you a lot of scaffolding, but I'm quite sure in 502, yep, same. In 502, we can manage it without too much help, you know. We can manage it using the red, blue, and green. Yes, Chris. Okay. Right. So that actually will save you a lot of writing. Okay, that brings us to okay. Trigo integrals, right? Actually, it's quite a lot. It's quite a lot. Let me help you to build up the way to learn trigo integrals systematically. Okay. Let me ask you. Do you know how to integrate sine x? I'm expecting a whole class to echo back. Yes, something. No. I'm not. Huh? Right. Do you not integrate this one? Sure. Do you not integrate sine square? Great. Do you not integrate for sine cube? Sine cube. Kaita, how do you do sine cube? Just describe to me. Okay, wait, roll back. Kaita, sine square, do you know? No? How do you integrate sine square? For sine square, right, you need a double angle, no? For sine cube, right, if you are in this trait, if you know this, you will need to rewrite as like that. Okay? How about Kaita? How about, and before you can finish thinking, how about to really master integration? What happened to what? Sine cube. I change the sine square to 1 minus cosine square. The sine cube is written as sine x times sine square. And the sine square is replaced as 1 minus cosine square. Okay, for the sake of calculation. Right. Okay, I write again. Cos square x. So suited there, you want to think, are you able to handle sine to the power 4, sine to the power 5, sine to the power 6? And the truth is, one day, some time ago, in fact quite long ago, I took the pain to write down the solution for the 6 of them. And not just that, Not just that. I then wrote down the solution for another 6. And then, like what you were trying to prompt me, actually I did go on to tangent, and I didn't stop there, I went on to, and I did it for cosecant, secant, and I did it all the way until it's still somewhere in my house. As the power gets bigger, the working gets longer. In particular, I just want to ask, among all the 36 possible integration for trigo, I just want to ask you, class, do you know how to integrate secant cube?
I don't remember the answer.
I can't remember the answer, but I know how to do. It's quite lengthy. I just need you to tell me roughly how do you think secant cube ought to be integrated.
Will it be asked?
It has never been asked in AP, but I've seen this question before long ago at the A-level paper. Maybe now that you ask me, maybe we should.
Maybe you should.
What is the time to explain all the way there?
In the other class, someone could tell me roughly how to do it. In the other class, 504. So I'm hoping that 502 can do likewise. I'm sure there are some bright spots. What is it again? Jethro, you're saying something?
I said no higher sound of 504.
Okay, actually, let me tell you again. It is to do it by parts. You have to do this question by parts. Some of you probably have a, yeah, secant x times secant square x and do by parts. So if you want to say, so-called have a mastery over the integration of trigo function, you have to first and foremost find a time, I think about 4 hours to write down the 36 solutions. But of course, right needs to be, I've done it before. It's somewhere in my house, just like because I shifted house recently, things go missing, so I got to, I'm going to do another shift. And then shift to a more permanent spot, then I'll start to unpack all the boxes. Right now the boxes are still in boxes. Okay. So one day when I unpack everything, I will retrieve it and then show it to you. Okay, so trigo integration, right? Minimally, you need to master these 36 of them. Apart from these 36 of them, right? To actually have mastery over trigo integration, you need 4 more things. You have seen this before, I am very sure. Just that you probably do not remember. And if you ask me how I remember all this, I'll tell you, it's by blood and sweat. I have already gone past the stage where you start to remember some other thing first to remember this. I've gone past the stage, You know what I mean? I just memorize just like that, Okay, so looks like Christopher has already mastered it also.
Wait, they give me this stuff in the formula?
Nope, not in our exams. Not in our school test paper, test or exams.
The school paper, they give like a bunch of formulae and
No more. The period of relying on formula sheet is over.
Oh, we never use it. I think they only give it that they tested this topic.
Okay, Kailash, what's the last one? Kailash, what's the last one?
it was just negative, I remember.
Not bad, yeah. Wow, you are right.
I just read it, that's why.
Okay, alright, so the mastery for trigo integration, you need the 36 plus 4. So it's altogether 40 of them. You need 40 of them for trigo integration. Believe me, with this 40, you can conquer integration for trigo function.
But that's just for trigo.
Yeah.
Then there's the others.
Yeah, but don't worry, because you're young, your brains can still develop. You still have a room for growth. Not that people aged cannot grow, still can grow, but maybe slower. Yeah. Okay, so there are altogether 36 of them. So maybe we want to try out some. Okay, like example 11 is an obvious. Okay, for example 11, I actually prefer to rewrite as like that. I like the bigger angle in front. I prefer the bigger angle to be in front. Okay, I prefer the bigger angle in front, And this we have already discussed. This is going to be sine. I think this is the standard approach. If you do it in any other way, you probably get the answer something that's equivalent but maybe lengthier. But if you do it this way, which is the standard approach, believe me, it is faster than what you think.
Wow, that's pretty fast.
Yep. You just have to memorize the 36 plus 4. as you're pondering over the part 2, let me say this thing, no. One day, if any of you become the Minister for Education, we should change the school hours, you know. 9 lah, 9. Too late also no good. Too late maybe like charging about 9 lah. 9 about just 9.
Yeah, actually.
In one of the local JC, they all start 9. One JC in Singapore. They report school at 8:45, but lesson starts at 9. There's one JC in Singapore that is like that. It's very good, very thoughtful. I don't think it end later, no. Human mindset is like that. If I start the school at 5 AM, right? Believe me, it still end at 6 PM. Anyway, I'm just telling you that there's one JC in Singapore, they all start at 9 AM every day. And then they report school at 8:45. Quite nice, huh? Quite nice. I feel sorry for you because even my own daughter struggles. And for the reason, I intend to leave just right across her school in March. So that she can just have more sleep. Hey, but you live in boarding, no? Yeah, I just realized you live in boarding.
But usually wake up, have breakfast and get ready and whatever. So I need to wake up early and stuff.
Yeah. Hey, actually, those who live in boarding should have no excuse.
The mindset generally that when you live closer, you can wake up later. But
Worse,
but most of the time when people do that, they end up late.
Gosh, don't frighten me, no. I'm doing everything for my daughter to have more sleep. I hope she won't be late. So for question 11, part and part 2, you just have to remember that 4 formulae, no? I thought in boarding there's a strict type light off counter. You don't check,
So by right, lights out is supposed to be 11 PM, but most of the time people just stay up past that, doing don't know what. Myself included.
Everyone.
Yes, everyone included.
I remember when I was undergoing training in the police academy, the line was very nice on, you know. We will get up about 7 o'clock, I think about 7 o'clock. Then 8 o'clock is our so-called food drill from 8 to 9. We go for food drill in the morning. Then after 9 o'clock, we wash up, we go to the mess to eat breakfast together. The mess is very big, I know. Quite nice. The breakfast is quite nice, like the police academy, very nice. Then about 10 o'clock or so, then we start lesson, you know. We police training is a lot of lesson, a lot of classroom lesson, not like military. So in the lesson, we will always have a lesson about law, local law, and predominantly it's criminal law. We study a lot of criminal law, and it's very nice to learn about criminal law. Then lunch about 12 to 1 is lunch. Then after resume lesson in the afternoon from 1 to 4. Then at 4 o'clock, we will go for recreation, you know. 4 to about 5:30 recre, you know. Then recre is very nice, you know. We got a lot of area to play basketball, football, everything. Then after that, then followed by dinner. Then evening time is own time, own target like you, you know. Then all of us will sleep at about 11. I think about 10 to 11 like that. But it's good life. I thought it's a good life. The boarding plan for you very good life. So that we are quite alert in the day. So you want to actually capitalize on the fact that because living boarding, you can afford to sleep at 11 and get up at 7, which is about good 8 hours of sleep. You just need to get up at 7, you don't need to get up so early, right? Who gets up before 7? Oh, why so early? Breakfast, what time you get up? 6 for what? Sorry. Why?
No, but today I was awake for the entire time.
Okay. I thought you live in boarding, getting up at 7 is about just nice. You wash up 15 minutes, you eat a bit of breakfast, you still have time to come to school. Breakfast ends what time? All the good things gone.
Yeah.
Oh, so must be early.
Yeah, need to be very early.
Oh, the early bird catches the worms. Huh? Quite clear. Couldn't you think of just get up at 6:30, run down the grab or breakfast, then bring back to your bring back to your bunk, then go back to sleep again?
but the issue is waking up after that. Because if you don't wake up,
That's what I did when I was in police academy. They have the fasting month where the Muslim friends, right? They go very early for breakfast, so I followed them to go breakfast. No, I ate their breakfast like them with them about 5 o'clock. Very early. No, after eating all breakfast, I went back to the bunk and then sleep again. Then I get up very late. Okay, so now I know why you gotta get up early. Yeah, the early bird catches the worms. So for this question, right? As I told you just now. You will just do it like this, and then this becomes minus cosine x plus cos x power 3 divided by 3. Okay. Okay. Mean. Where are you? Okay. Mean 12 part 2. How do you think I do? I'll go about 12 part 2. Huh? Nope. Okay, just tell me what formula do I intend to use after this line mean? Formula 2, 3 or 4? You know my formula, right? I wrote down 7 for you all last time. So for this one, after doing this line, which formula do you think I'll use? 2, 3 or 4? Nope. Mean 2, 3 or 4? Okay, you said 1, right? It's formula 1. Scammer.
Scammer.
1, right? It's 1. Scammer. Apparently, it is your age group or slightly older age group that get conned more easily. Interesting. I read the news. It happened to I'm not really conned. My daughter unknowingly when she was much younger. You know the Roblox, is it Roblox? How to get Roblox?
No.
I didn't know. She didn't know. Rather, she didn't know that she got buy all those special weapons or what or gadgets in the gameplay itself. So she used the mobile phone. She was quite young at the time. She would just keep buying, and then they send her a code on the phone. She entered the code, and the payment goes to the phone bill. And she chalked out how much $600. Very legit. When I saw the bill, I thought it was a mistake. At the time I was overseas, I saw the bill. I said, hey, maybe it's a mistake. Maybe when I was in China, maybe I read wrongly. So when I came back to Singapore, I see again, it was $600. I got shocked my life. And I started to dig out what actually were the charges. And I found that it's all the Roblox gadgets, I was shocked. I didn't know that a child with a handphone can buy things like that. I didn't know.
Yeah, directly connected to the.
Yeah, it was charged to the phone bill. She was good enough to know that it entered a code, but she didn't know that this cost real money. And the worst thing was she was buying all these gadgets for her friend, you know.
What you go for?
So this game of friends,
I don't can send to friends or something like that. I'm not so sure how it goes. I don't know how to play. You guess what? Did I pay for it?
Is the latest Mr. Beast video?
Did I pay for the $600?
Yes.
I called the telco, and then they say some of this gadget can reverse charge, so no charge. Some just cannot. Some really consume cannot. No, she said there was a code sent to the user, and the user entered the code, so it's considered a done deal. So out of good heart, they say those that can reverse, they reverse for me. That was the Apple side, you know. The call Apple, because I called telco was called Apple. Then I got released. Then in the end, they deduct some, but still quite hefty. So did I pay for it? I didn't. So I called the telco again and made a lot of noise. I say, how could you actually have such a payment gateway for user? Then I say, but because it's a legit user and the phone is registered under my name. Then I say, look, how do you expect a child to register a phone under the name? Must be parent's name, So I told her I refused to pay. Then the thing went back and forth a few times. In the end, I still refused to pay. And then what I did, I wrote to the CEO of Singtel, and I wrote to MAS. I said this actually is actually bypassing the bank, because I didn't know that now the telco acts like a bank, that they can do collection payment for a third party, Apple, that way. I said I didn't know, totally ignorant, and said this has become a danger for a young user. I wrote to CEO of Singtel, and guess what? It was waived.
What? She got free gadget.
After no, everything all minus off lah. Minus off. Yeah.
The stuff probably
also no more gadgets.
Yeah. Okay. Anyway, that was my story. Okay. Min, back to you. Just now you're too soft. I couldn't hear you, and you didn't guess one. You guessed. Is it 5 or 6? Okay, Min, this one. Come. You're now more empowered to do this question. Shh. Let's hear from Min. Right, sine 2x. Right, you gotta do this now. This one got no shortcuts, you know. This one apparently has no shortcut. You have to do the painful way, you know. And then it's a painful process that you go through, no shortcuts that I know of. So as young user, right, you're very careful now. There could be some scammer. So lucky for our case, I know our case. But actually, in a way, it's like cheating a young child, because younger at the age, I didn't know what was going on.
She didn't see money, so it was free.
Huh?
She didn't see any money, so it was free.
Free. No, we just shut down the account, the Roblox account. Just shut it down.
Oh my god.
I banned her. I banned her. Huh? Is she good? Sorry.
Was she guilty?
She didn't understand.
After the incident.
She didn't understand. So, of course, I did punish her for not asking me before committing to a purchase.
She didn't know it was a purchase in the first place.
She knew. She didn't know the value of it. She didn't understand the value of it. Yeah.
I'm quite sure most of us support your decision to ban her from that game because that game has a lot of controversy also. Like,
Oh really?
throughout throughout the school and I think over the internet as well. There's a lot of like,
Okay, good thing, good thing. It's not all because a friend of hers, a neighbor friend, say wanted a gift for her birthday. That's all I started. My daughter told me that. Yeah. But of course, I did not go and knock on the neighbor's door and say, hey, cannot do that because my daughter's fault. No, I didn't argue. I wrote a letter to explain to them that this is wrong. That a telco cannot act like a bank to collect payment for a third party. Then it cannot. And then it did not warn a user the danger. You know what I mean? That this thing is happening. It's wrong for a telco to act as a bank. A telco should only collect money for their own services. I would say I was lucky that the CEO obliged, but I'm not sure the next attempt will you get off, Yeah. When I shared the story with my colleagues say they also have similar encounters with their young children, Yeah. So next time when you're parents, right, the first thing you do is you want to subscribe a plan for a child and add a clause that cannot do any kind of monitoring transaction. There's such a clause in the contract, and you can do that. Okay, anyway, in example 13 of the notes, it is all done deal. The questions in this example is show you how you can do for these few questions. By the way, for this part 4, right? I want to tell you something. Part 4 is totally memory work. It's kind of a no-brainer thing. It's just memory work, right? The only thing you need to take note of is you need to divide by 3. Okay. So maybe with this, we take a few minutes break. We resume at 9. Go and get yourself something to munch, eat, get a drink, and come back. I'll wait for you. Your classroom is very good, It's right near the canteen. Integration by simple substitution. You learned it in earlier year, You learned that to do substitution, like this question, right? Do you remember how to do the substitution? Typically they will tell you, and once you know the substitution to use, like this case, right? It tells you to use this. Once you know the thing to use, the rest is just mechanical. The only thing that you need to worry about is when you do it by substitution, the whole idea here will therefore be equals to x squared, x cubed into x squared minus 1 dx du, and the idea behind is you want to change this one entirely to become u. Okay, change everything to be in terms of u. So how to change everything in terms of u? This becomes okay. This becomes in terms of u, right? In terms of u, the x cubed will be x times u plus 1, and this is u. Dx du, right, is 1 over 2x. You realize that in this question, I have actually keep this as x still, knowing ahead that there will be some kind of a nice cancellation that will happen. I did not rush into changing every x in terms of u. I did it with anticipation that down the steps the x can be wiped out. So after wiping out the x like this, everything will be in terms of u. So that this one can now be written as half u to the power of 3 over 2 plus u to the power half. For this kind of question, right, after doing the integration, right, and you get answer in terms of u, it is crucial for you to remember to do that one important steps, you know. After integrating, right, you must change back the u back to x's. Okay, the indefinite integral. There are people who forget to do so, no? Then there's another example to show you similarly by substitution. The whole idea is to change from x's to all the u's, okay? So this example you can read slowly at home for yourself. We want to do one example here. Why don't you try? This question is nice because it doesn't even tell you what to use. Let's hear from Zheng Hong, you know. Zheng Hong, how? You okay? You awake already? Zheng Hong is very tiring, is it? Very tired. Okay. Zheng, you want to start the ball rolling? You want to tell the class what do you use? Okay, Zheng, let's hear from you. What do you use? Let's what? Let u equals to x. You're saying this, right? You meant this. Yeah, you learned the trick. Do you think that if I let you be this one, do you think it'll work? If I let you square, okay, sorry. Okay. Do you think that the second one will work? Maybe some of you try the first one and some of you try the second one, you know. Okay, some can try the first substitution, some can try the second one, you know. So supposedly I try the second one. I guess most people who actually use the first one though. Let me try to do it using the second one, okay? So you find that using the second one also works, you know, which means the substitution you use, right, can vary, you know, and two different substitution can work just as well. If you use the first one, you potentially have to apply partial fractions, you know. You don't have to. Okay, so maybe my guesstimate was wrong. Okay, so so for those who did the first one, it was just quite easy, is it? A bit, is it? Yes, du. Okay, so it's 2u, right? 2u du. Yeah, just a little bit, just a little bit. Right. If you do it by the first substitution, you got the either you say partial fraction or you do it by the so-called long division. You know, depends on. So both of them will work. both substitution will work. Okay, that is example 15. I differentiate this one as dx du. I've made x the subject first. I find it easier to make x the subject first and then differentiated it.
Oh no way.
Okay. Sơn Huy, okay? Stephen, you finished copying? Okay, good. Okay, in many textbooks, they document a short list of standard substitution, you know. You might want to actually memorize the short list, and along the way, you might want to develop the art of come up with your own, you know. Like example 10. Example 10. What do you think you want to choose? Because it involves 1 minus x squared according to the list on top, you want to let x be sine x. Oh, sorry, sine u. Okay, sine theta lah, sine theta, right? Sine theta. Make it theta. Okay. So now to do this one using substitution. And then dx d theta. This becomes cosine theta. Okay, give yourself that 30 seconds to finish it up. No, I think more than that. I think you need about 2 minutes to finish it up. 2 minutes. Is it the fan that's causing you to? Is it the fan? Maybe the fan. No, not the fan. It's just the air around you. You got an air purifier now? Sure. Where's the air purifier? Oh, maybe someone can bring over and put it next to you. Maybe it may help. Like, give yourself that a bit of time to finish it up nicely. You must bear in mind, you must replace it back in terms of x, you know. I'm managing some urgent office matter. Just be while you try. Okay, so for here, right? Okay, let's see who got to this line already. Because you cancel the cosine, right? Right, then become cosecant. The integration of cosecant is known to be what I've written down. Is in a, you know, you may like call it is part of the formula. No? Is but it can't stop here, no? It can't stop here. Remember I told before, because it must replace back. So if your x is equals to sine theta, right? If x is sine theta, this is 1 minus x squared. If sine theta is x, cosecant theta will be 1 over x. If sine theta is x, cotangent theta will be this fella. Okay. So this is a little bit tedious, Yes. Yan say. I can't hear. Why is that negative here? Is it? Okay, there are two versions. The notes version doesn't have negative outside, but it has negative inside. You look carefully. The version that I always remember is this version. They are equivalent. This version is actually the version I remember, and also the standard version is given in typically the formula booklet, no? In most standard exams board, you know. This is the standard version given in most formula booklet. So I hope that answers the question. It's equivalent. Yes, Ryan? Same question, is it? Okay. Any question to raise? Yeah, I welcome question. Please raise.
How do you get from step 3
This to this, is it?
No, this one.
Okay. Because after the cancellation, this becomes integrating cosecant. And to integrate cosecant, I told you, it's actually by formula. The formula for integrating cosecant is actually this. It is something that it differs slightly from your notes version. Yeah. As I told you, it's a choice. But the more remember, the better you are in integration, right? So you want to actually accept this truth, that integrating this helps. No, it's not horrible to derive. Let me show you how to derive, Let me show you how it is derived. It is easier than what you think, Let me do it for you, since we are on this issue, If we have to integrate cosecant, what people do is they multiply this with cosecant I didn't think of this. I was a diligent student. I read the book. Let's face it, we learn from people. And because of this, I can now apply the formula. What formula do I apply? Formula 1 again. Sorry, formula 3. Formula 2 rather, formula 2. Remember formula 2? This becomes ln of the denominator. That's why it becomes minus ln of the, okay, so the proof for this will lead us to a plus rather than what is given the notes as a minus, because the notes have brought this minus up, you see, and then you do some tidying up some more. But at face value, this is the first cut. So that's why I remember this version. And I thought this version is so easier to remember, no? Because the plus inside, is it? Because in the minus is inside, you can remember, is it the cosecant minus cotangent or cotangent minus cosecant, right? Ken, Ethan, you good? Are you still tired? Are you tired today? After my lesson is PE, right? It's recess. Oh.
It's Thursday.
Okay, let's press on. Okay, so I hope that resolved this question, you know. Okay, this one is okay. Do you remember this one? To do this kind of question, do you remember you're gonna let something to be u and something to be dv dx? Do you remember? Okay, let me just test you out on something basic. Basic. If you have to ever do by parts for a question that's like this, if you had to do a question like this, Bunny, how do you do the by parts? Oh, don't remember. For me, I personally do not do by parts. By first letting u be this, dv dx to be this. I don't, you know. For me, I was trained. In fact, I like this way. I was trained to actually do by parts. By remembering that you always choose one term to be integrated and one term to be differentiated. So I choose to differentiate this and I choose to integrate this one. In my head, I will see a d and an I. And how do I do by parts as a student? No, I will remember that the d is left untouched. I integrate the I. Then integration sign. Nothing stops you from going back to the good old ways, but I'm just showing you what people do out there. Within the square brackets, I will differentiate my d, I will integrate my I. So I remember this in my head, you know. And then when I do it right, I won't write this thing down. I will immediately keep my d, I will immediately integrate my I. And then if I do my steps correctly, I will realize that inside this bracket, you will always have a repeat of what you have done outside, except that integration is done 2 times, whereas differentiation is done only once. So that's how I remember it. To know that I'm doing rightly, I remember that I've done the same integration twice on the first step. And then the one to be differentiated, I need differentiated once. Then I'm quite done, you know. So if you think this way, then maybe your by parts becomes neater. Why I'm trying to advocate this, no? Because sometimes in the working for by parts, it can become very cluttered, you know. Why is it so? Because sometimes you have to do by parts more than once, right? You have your u and dv dx all over, no? It becomes very clumsy. So for me, if I do by parts, right, I really do not have this one, you know. I don't write this thing. And in my mind, I see who is to be d, who is to be I, and this is my working. Clean working. No need to have too many u or dv dx. Just a show of hands, who does it this way? I'm sure there are some people. Okay, sorry. So you might want to adopt this, no? How does it work again? The d you keep, the I you integrate once first. Then minus. This is not my method, you know. I learned it as a student. My teacher was quite good. And I like the way she did by parts. And today I'm stuck with it. It's more elegant to be able to do by parts without having to write U lah, DVDX all over. No? It's the same thing, just as more elegant presentation, that's all. It's like two sides of the same coin, you know. One side got more colors than the other side, that's all. So I'm not sure whether or not you're prepared to follow the leader and want to change the way you do by parts. So if you're ready, you know, you want to do by parts like what I just said. Okay, how I do by parts now? The D, I leave it. I integrate the I once. The D, I differentiate now. If you do it correctly, you will see that the integration is done twice on the first step. As a way to check, you know the integration is done twice on the first step, and then your steps are just finished. Nice, right? Neat and clean, you know. Okay, so I hope you can try by parts using the way I think in the next few questions, you know. And with this, I will end my lesson so I can go for a